Greetings and welcome to the class where we learn about how ecological systems are influenced by people. We call these urban ecosystems. I'm Kelly Conrad Sima and I'm the urban wildlife biologist with Texas Parks and Wildlife for the Austin and surrounding urban areas. This presentation is being presented as a pre-recorded video, but I'm here with you and sitting in the chat box or the comments area. So during the presentation, that's where we'll interact, there in the comments or chat. Sometimes I'll even ask questions and pause so that we can collect your responses in the comments and then discuss them. But at all times, you're free to jot a question in the comments or the chat window. And in this way, we can have a lively interaction, but the flow of the presentation isn't interrupted. There'll also be a little time at the end where I can take some of the more complicated questions that were posed in the chat window and expand on them a little bit. So let's dive in. Today we'll begin by examining the characteristics of habitat and then take it to a larger scale and look at the characteristics of an ecosystem. Then we'll look at the urban ecosystem in particular, the characteristics of urban ecosystems, the challenges posed by ecosystems impacted by people, and then how we might be able to meet those challenges by evaluating their impact and managing them to bring the system back into balance. So let's get started with habitat. What is habitat? We tend to think of habitat as nature, way off and undisturbed and in large amounts. So is this habitat? This is a good time to start chiming in the comments. It seems pretty and natural enough, this habitat, but is that what habitat is? Just pretty? Because perhaps this could also be called a habitat. Great-tailed grackles find McDonald's and H-E-B parking lots irresistible. But it isn't tucked away out in nature. It's right in the middle of suburban cities. So that begs the question, does habitat have to be big and away from the city? These two houses are on just 1/4 of an acre in the middle of suburban Austin. The one at the top is a more traditional landscape, and the one at the bottom is more naturally landscaped, using plants native to the area. But wild things live in both areas. Ask any gardener who's battled pocket gophers or armadillos. Both landscapes can and do support life. So it seems that all these landscapes can be called habitat. Something lives, feeds, and reproduces in each of them. They support different species of life, even when they're right next to each other. And as a wildlife biologist, I know that the habitats on top will support a diverse array of wildlife, while the landscapes on the bottom will support mostly species who can use just about any habitat. We call those generalist species. They can be native, like the great-tailed grackle and raccoon, or exotic, like the European house sparrow or domestic cat. All it takes for something to be habitat are the 4 elements of food, water, shelter, and space. Now, they're all habitat, but we know that different kinds of species will inhabit each landscape. So what kinds of things do you think will affect what will live in each habitat? Okay, I've done this presentation long enough to know that you've probably come up with some interesting and insightful thoughts about what kinds of things might affect the quality of any habitat. And I bet that most of your answers could fit into one of these categories. Ecological systems can be categorized by their biotic and abiotic components. Some of these components include the soils, temperature, water, flora, and fauna of the area. And I also add humans too, even though they could technically be considered fauna, because in urban ecosystems, humans have a very large impact, not only on the ecosystem itself, but every other factor that contributes to the ecosystem as well. Remember that through this main part of the presentation, I'll be presenting information in a familiar pattern. We'll take a component of the ecosystem, soil, temperature, flora, fauna, water, and humans, and look at the characteristics of that component in an urban ecosystem. Then we'll look at how we, as natural resource stewards, can evaluate the state of each component and what management techniques we might recommend to support the healthiest, most ecologically diverse landscape possible. The first component we'll look at is soil. What's the first thing we do when we want to build something in an area? Yeah, we clear all the plants off the land and then push the soil all around. Now, there are very good reasons that we do that, water management being a big one, but it has a huge impact on the soil profile. You might remember from your soils class that soil has a distinct profile. There's topsoil at the surface, rich with organic material, generally a velvety dark color, and hopefully covered by a nice cushiony layer of decaying leaves and other organic matter. This is the primary rooting area and where most microorganisms live. Then a little deeper is a layer that's lighter in color, where fine minerals like clay, carbon, iron, and gypsum are collected through the movement of water. This is called the subsoil and is also the zone of leaching. Farther down, deeper east of I-35 and almost on the surface in the Edwards Plateau, you'll find weathered rock fragments. And deeper still, you'll find bedrock, which is the large, solid layer of rock material, sometimes called the parent material of the rocks found higher up. Unfortunately, with our expansive use of heavy equipment, we compact the soil, crushing the pockets of air and water that are critical for supporting life. We also remove life and decaying vegetation from the surface of the soil, exposing that soil to solar radiation, wind, and water, which heats it up, makes it less able to hold water. The water runs off instead of percolating in, and makes it more vulnerable to erosion from water and wind. And some of our activities, from discarding antifreeze and used oil to even over-fertilizing our lawns and gardens, also contributes to the pollution of the soil, ultimately making it less able to support a healthy diversity of life. So let's say you, as a master naturalist, are asked to come and help provide some recommendations for a potential new neighborhood park where the residents want to create a great bird watching spot. The first thing you need to do is evaluate the property. So let's take a look first at the soils. The most obvious thing to look at are whether and how they've been moved and their exposure to the sun, erosion, and pollution. Make note of the evidence you see. Is the soil crusty? And what kinds of plants are able to grow in it? Are they weeds? Those species that we call weeds grow where they do because nothing else is able to grow there very well. They are really good at using soil that has a high mineral content and low organic matter. And they act as kind of a band-aid, regenerating the soil by pulling up the good minerals, breaking up the heated and dried soil, cooling the soil with its shade, and replenishing the organic matter as its leaves fall and decay. Weeds aren't bad. Given enough time, they'd actually heal the soil. But what can we do to help speed up that process? Well, we can protect the soil from heavy equipment, compaction, and pollution in the first place, if possible. Seek out techniques that confine heavy impacts to smaller areas, and consider mulching to cushion and protect the area that must be impacted. You can also return nutrients back to the soil faster by adding compost and other organic fertilizer. The next component in urban ecosystems is temperature. I'm sure most of you have heard about the urban heat island effect. The highly reflective and impermeable surfaces, roads, roofs primarily, reflect the sun's heat into the surrounding atmosphere, heating up the area around the urban core. This sketch shows how the temperature at the inside of the city will generally be a few degrees higher than the temperature out in the suburbs, and the suburbs will be a few degrees higher than rural areas, but that urban parks can actually help reduce that effect. When evaluating the urban heat island effect in your neighborhood park, you might consider the hardscape, the materials that make up the sidewalks, parking areas, and buildings, and compare them to the available vegetation, shade, and permeable surfaces. The urban heat island effect is usually talked about at a large scale, but this urban park can have a big effect if you address each of those elements. To address larger scale temperature management, city ordinance might even be considered. Things like development codes that require permeable surfaces or canopy cover would address some of these issues. Within the habitat of the park, though, you'd want to reduce hardscape, increase the canopy cover, use mulch, gravel, or other permeable surfaces along the trails rather than concrete when possible, while still considering accessibility. Increased tree cover when appropriate can also cool the air through shading and also through transpiration. The next category is water. Topsoil cracking like this indicates that the soil has a high mineral content, clay, and pooled water has evaporated. The cracking exposes more soil to the air and increases the rate of evaporation and leaves soil very dry, difficult to work with reduced water holding capacity. On the bottom left, pooling of water suggests that soil compaction has happened. And on the bottom right, ripples of detritus or soil indicate that water has been moving very fast over the surface and not permeating. It indicates flooding and soil compaction. In order to better manage water, we need to allow it to percolate into the soil. So reducing impervious cover, where possible, is a big help. Channelization, generally used to manage floodwater, only pushes the problem farther downstream. Once impermeable surfaces are reduced, consider other ways of slowing water and preventing flooding. The use of tall grasses and ephemeral runoff ponds can be especially helpful. Shrubs and trees planted along waterways will provide shade, which lowers the temperature of the water and increases the dissolved oxygen content of the water. This one thing can make a huge difference in the types of life that can be supported in a body of water. And speaking of revegetating areas, when making recommendations for the management of water in an area, it's really important to recognize the individual roles of grass, trees, shrubs, rocks, and soil. Trees provide the large roots that act as a rebar to hold the soil, and shrubs break up the rain as it falls, cushioning the soil. Tall grasses have extremely thick fibrous roots and deep roots that capture and hold water and then release it slowly back into the soil and water table, and the soil holds it all together. The fourth component of ecosystems are plants, the flora of an area. You might also consider or include fungi and algae in this group too. For any forested areas that haven't been cleared, people like to clean up the vegetation by removing shrubs and vines and limbing up the remaining trees. This isn't always bad, but removing an entire layer of the ecosystem's vegetation will definitely change which species can use it, since some species either nest or feed exclusively in those layers. But of course, many areas have been cleared of vegetation. After the soil has been moved and cleared of vegetation, people generally want to plant some back. They use plants available from wholesale plant nurseries whose stock is dominated by exotic or genetically modified or cultivated varieties. These species frequently don't provide the pollen, fruit, nectar, or other resources that many beneficial species need to survive. They might as well be plastic plants as far as the birds are concerned. Also, the bits of vegetation that are remaining tend to be broken up by roads, buildings, or other development, which fragments the habitat. Fragmentation makes it difficult for animals to get the food, water, and shelter they need all in one place. And frequently they'll need to cross roads, buildings, fences, or other structures every day to find the things that they need to survive. Finally, changing the suite of plants in an ecosystem will also change the function that those plants provide. For example, in native grasslands, native grasses generally grow in bunches, and some species of bird need those bunches in order to nest. The turf-forming grasses, like Bermuda grass, don't provide that bunched structure, and so the birds can't nest, even though a pasture might look just like the grassland it replaced. Plants also break up rainfall, shelter the soil, and provide nurseries for other plant species. Riparian habitats, those areas along the rivers and streams, usually are rich in different species of trees, shrubs, and grasses. However, when an exotic species like ligustrum comes in, it invades from nearby home landscapes. It efficiently shades out all the shrubs, wildflowers, and grasses, and the area becomes a ligustrum forest. Without the understory, rain erodes the soils and the river fills with silt. The entire riparian ecosystem changes just because of the invasion of one species, exotic ligustrum. So when you're evaluating your neighborhood park, you're going to look for layering. Are there appropriate canopy, understory, and ground cover layers? What are the layers made of? Native species or exotic species? Are they early successional weeds or higher successional levels? Is there variety and diversity in the species? Finally, does the landscape have larger, unbroken natural areas? Are they perhaps connected with other contiguous habitat blocks? Are breaks minimized? Could natural areas be connected to enlarge the habitat and reduce edge, or the margin between habitat types? Evaluation of vegetation is one of the quickest ways to understand the condition of the landscape you're evaluating. So let's take a closer look and see what you can read from a couple of examples. Here's an easy one. You're at a garden at the proposed neighborhood park. In the garden bed, there are an abundance of this species. Do you know what they are? What do they have in common? Right, these are weedy species. We got burr clover, lamb's quarter, partridge pea, and Texas panicum. These species thrive in areas of soil disturbance. They can do well in poor soil where other plants can't. So I think perhaps this soil has been moved or overworked. There's not enough organic matter in it to support other, perhaps more desirable species. Here's another one. Let's say you're evaluating a neighborhood park, again, in western Travis County. As you move around the property, you find lots of these species: agarita, ash juniper, tasajillo, Mexican buckeye. Think about what this kind of habitat looks like. What can you tell me about them? Are they palatable? Do you know if anything likes to eat them? What I know about these species is that species that eat twigs and new growth, like white-tailed deer, they don't like these species. So they do pretty well, even under heavy browsing conditions, while other, more palatable species are eaten. In areas with lots of deer, maybe an overabundance of deer, you might find lots of these plants and maybe not many others. Maybe like redbud, red oak, snail seed vine. So what do you think is happening here? Well, the deer are hungry, eating not only an unpalatable plant's leaves, but also its twigs. Although the mature oak and juniper trees are often tall enough to escape extensive browsing, overbrowsing still has a devastating effect on habitat because it removes all the seedlings and saplings that would eventually develop into mature trees. Overbrowsing also removes other understory vegetation, shrubs, grasses, wildflowers, that are essential for preventing soil erosion, for protecting water quality, and providing habitat for a large range of animals, including the endangered black-capped vireo and golden cheek warbler. Plants affect wildlife, affects plants, affects soils, affects water. Everything works together. So how do we manage vegetation? Broadly, do things that reduce those negative effects. Restore the understory where it's appropriate, though it isn't always appropriate. Eradicate or manage those exotic invasions. And by doing those two things, you'll start to see changes in diversity. Well, keep working toward that by including more and more native species, as appropriate, to the habitat. Connect blocks of habitat with corridors of native vegetation, but be careful to not create too much edge. Of course, people work a lifetime to understand and manage their vegetation, but a lifetime of work has to start somewhere. The sixth component of an urban ecological system are the wildlife, or fauna. Wildlife populations in urban areas tend to be dominated by generalists, species that do pretty well just about anywhere. They're able to use whatever resources they find to survive in an environment that has lots of disturbances, like urban habitats. It's worth noting, however, that in stable habitats, specialists, those species that require specific habitat elements to survive, can outcompete generalists every time. Think of it as the home turf advantage. Specialists have it. Also, species that eat grain tend to do very well in urban areas, and maybe that's because there are so many people interested in providing feeders for wildlife. However, even urban wildlife watchers tend to not tolerate many predators, so you tend to see prey species in abundance. Rabbits, squirrels, and rodents who would have been kept at much lower population levels in rural areas tend to do very well in urban areas. Those exotic species that survive their transplant into a new habitat are also either generalists, so they'll do pretty well in just about any habitat, or are lucky enough to have landed in a special habitat in their special habitat niche, but without the predators that they would have at home. If either of these conditions are met, exotic species can become invasive and outcompete our remaining native species. And urbanization tends to alter behavior too. Higher temperatures and streetlights mean that the breeding season can last much longer for some species. Mockingbirds and grackles, for example, have much higher reproductive success in urban areas. More nesting attempts per season and more surviving nestlings per nesting attempt mean an even greater population number. Just like with Flora, to evaluate the wildlife of an area, you need to look at the species composition. Look for diversity, exotics versus natives, levels of species who have explosive growth in urban areas like great-tailed grackles and raccoons. Okay, so let's do another practical here. We're at that proposed neighborhood park again, and while there you see these species. First, who are they? Right, raccoon, blue jay, and house sparrow. So what can you tell me about them? I'm sure you've all got it. They are all species that do pretty well just about anywhere. They're generalist species. In fact, you can find raccoons in much higher densities in urban areas than you would in rural areas. They don't call them trash pandas for nothing. House sparrows are exotic species that are generalists and granivores to boot. They aggressively take over nesting spots from native birds. And blue jays are native, but they are efficient predators that do very well along the edge habitats that dominate urban areas. So how do you manage wildlife in urban areas? It's really more difficult to manage wildlife in urban areas than it is in any other element. Many of the tools that you might use in a rural environment like hunting just aren't available to you. And also people are emotionally attached to animals, so management has to be done collaboratively, slowly, with lots of input from the community. That said, one of the easiest things to do is to be mindful of intentional or unintentional feeding. Shelter can be provided for species that are resilient in urban areas and just need a helping hand, like chickadees, bluebirds, and even frogs, salamanders, and turtles. Water is a very easy thing to provide that all wildlife need, and it doesn't artificially increase the carrying capacity of the land either. It's also very beneficial. Finally, exotic and pest species should be managed if possible, so that those resources can be used by a variety of wildlife species. So that's the bulk of the presentation. We've looked at each of the components of urban ecosystems. We've seen the challenges posed to them. We know more about how to evaluate them in the landscape. And we understand a bit about how to make recommendations for managing them so that they can provide a balanced, healthy habitat for years to come. But if there's one big overarching theme that I hope you come away with today, it is this. All the components that we've talked about, the soils, the temperature, the flora, the fauna, and the water. They all work together to make a unique ecosystem, and a change in any one of these parts changes the system. Of course, that doesn't mean that the world just stops turning, but it does mean that the relationships between these elements are going to change, and it will have an effect on the way that the system works. And I say all that to say this. The element of an ecosystem that has the most significant effect on all the other parts in the urban area are humans. We impact all the other elements in significant ways, and so we've changed the ecosystem. That's why we talk about a place being in an urban area in a forested area of the Edwards Plateau, for example, rather than just a forest ecosystem in the Edwards Plateau ecological region. But the underlying ecosystem, a forest in the Edwards Plateau, that's the machine that humans affect. And what are some of those effects? Urban areas are defined as places where people live and work, generally at non-agricultural jobs and with infrastructure and government. So there are lots of landowners in a smaller area, making lots of different land management decisions based on their own values and goals. And because sometimes people's goals conflict, there are laws and ordinances in place that restrict or require certain activities. And those ordinances will have an effect on the soils, water, flora, fauna, and even temperature of the city that they govern. Of course, Texas Parks and Wildlife, we're part of the government and we're here to help. And we know that the key to good management is to work with private landowners. So let's take a look at that. This is a property out in the hill country. It's typical of the kind that my colleagues would provide technical guidance for. It isn't large, it isn't small. It's about average for those that they provide technical guidance on, and it measures about 500 acres. And this is how it goes. There's one landowner here, and they might live on the land, or more likely they live in Austin or San Antonio. And this one landowner and their family decides that they would like some assistance with their wildlife management. And maybe it's because they got an agricultural exempt or agricultural valuation, Or perhaps it's because they want to manage their wildlife to provide good hunting opportunities for or experiences for their guests, usually paid guests. Anyway, they're scheduling a meeting. They schedule a meeting time, they sign some forms, and my wildlife biologist colleague would drive out to their property. And there they'd tour the property, examine the deer browsing intensity, evaluate the condition of the species of vegetation, check out water sources, and overall they just evaluate the health and potential of the land. Well, then they'd write up their recommendations. And the landowner agrees to implement some or maybe even all of the recommendations. And then that biologist usually keeps in touch with that landowner annually to see how things are going. 500 acres, one landowner and their family, one land management plan, good practices continued for as long as that landowner has the land. Now let's look at that same area in an urbanized landscape. Here's a place in Houston, Texas. The human density is about average for the suburban areas of the city. I found a subdivision that's about 500 acres, about the size of the one that my colleague was working on out in the hill country. Here's what that 500 acres looks like. And I counted the number of individual homes that fit inside that box, and there are about 2,100 homes. So I checked the 2010 census for the average number of people in this part of Houston per home and calculated that there would be about 5,649 people in this one 500-acre area. To affect the same amount of land, less actually when you consider that the houses, the land that the houses sit on, I'd have to contact at least 2,100 people, one person per household, and persuade them to make good habitat management choices, without the carrot of a favorable tax valuation or enhancing their hunting revenue. And to put it in even more stark relief, let's look at that 500 acres in context of the city. There it is, right there, that tiny little plot of land in the southwestern part of Houston. So, that's where you come in. Texas master naturalists are one of our answers to the problem of reaching so many urban residents in Texas. Texas master naturalists have volunteered over 2 million hours, touching over 300,000 youth, adults, and private landowners through hands-on direct communication in the classroom, one-on-one, and through group instruction, and exponentially more than that through providing booths and other indirect education opportunities. You've affected over 180,000 acres and 180 miles of hiking trails. The economic impact of Texas Master Naturalist volunteers has been calculated at over $32 million. Your work matters. Each of you are extraordinarily valuable in the work to conserve Texas wildlife and habitat. Thank you. So that's it. I've been delighted to be able to talk with you today through this presentation and also through the discussions we're having over in the chat window. Thank you for inviting me, and I look forward to the time that we can all meet again in person.